All right, today we're looking at fundamental theorem practice problems. This will also involve problems with rates going in and out. You'll also see some of the theorems in these types of questions too. All right, so our first question, it says a store tracks sales of one of its popular board games over a 12-week period. The rate at which the games are being sold is modeled by the differentiable function g. So we're talking about g is a rate, and that rate is measured in games per week, where t is measured in weeks. And again, we're only going from week 0 to 12. And they gave us some values for g in the table that you see. All right, so part A says approximate g prime of 8. So looking at the table, I noticed that I don't have 8 in the table. And they're also asking for the derivative of g. So I'm going to go ahead and approximate it using my average rate of change, or my y2 minus y1 over x2 minus x1. And I'm going to do that between 6 and 10, since I know that 8 falls between there. So simply plugging that in, or using the table and then simplifying that, I get 300 games per week. All right. And again, on this one, it did not ask for units, so you did not have to put the units on that. All right, part B says approximate the value of the integral of from 0 to 12 of g using a right Riemann sum with 4 subintervals. And so again, I'm just simply pulling the data off the table using my right Riemann sum. I also noticed that my intervals are not even, so I have to do it separately. I can't just do like one big equation. I need to do each one separately. So between 0 and 3, I know that change is 3 times my right Riemann sum would be times the 400. All right, so this 400 down here. And then from 3 to 6, that change is 3. And then I'm going to use the right of that interval, which is 900. From 6 to 10 is 4. On the right hand side of that, I'm using the 2100. And then from 10 to 12 is 2. And then I'm using the 2400. Again, just adding all that up with my calculator, I get 17,250, which that number represents the total number of games approximately sold in the 12-week period. Part C says that one salesperson believes that starting with 2,400 games per week at t equals 12, the rate at which the games will be sold will increase at a constant rate. When I read the word constant rate, I automatically think in my head linear, all right, because linear functions move at a constant rate. And so that constant rate, they believe, is 100 games per week. Based on this model, this salesman, how many games will be sold in the 8 weeks from 12 to 20. So again, I read the word constant. I'm like, yo, that's linear. And so the first thing I want to do is figure out my initial point, or have a point on that function, which they told me at the very beginning. At 12 weeks, we sold 2,400 games. Again, with that constant rate, I know that my slope is going to be 100. And so now all I'm going to do is plug this into my y2 minus y1 equals mx2, or x minus x1. All right, so just plugging it into my linear equation. And then I solve for y just to get a nice, pretty equation that I can go ahead and integrate. So I have R of t, or the rate at which these games are being sold, equals 100 t minus 12 plus 2,400. Again, all of that came from the fact that I knew it was a constant rate, and I knew it had to be linear. From here, I'm just going to integrate it from 12 to 20. Using my calculator, and I get 22,400 games. Part D says that we have some other salesman that believes that the rate could be modeled by this function m of t. And based off of his model, or her model, how many total games were sold. So this one's pretty easy. They gave you the function, and that function is a rate. So all I need to do is integrate that from 12 to 20. Throw it in my calculator, and I get 15,784 games. All right, the next question says that we have fish entering a lake at a rate given by E, and then we have fish leaving a lake given by a rate of L. So a very common problem on AP exam are rates in and out, right? So you got something entering and you got something leaving. All right, so both E and T are rates, and they're rates in fish per hour, and then T is measured in hours. All right, so part A says how many fish enter the lake in this 5-hour period from 0 or from 5 a.m. from 0 or midnight to 5 a.m. And so again, we're talking about fish entering. So the only function I'm concerned about is E. So I'm going to integrate from 0 to 5 E of T using my calculator, literally just plug it in, and I get 153.458. So that tells me that about or roughly 153 fish enter the lake from midnight to 5 a.m. All right, so for this one, you're going to get 1 point for setting up the integral and then 1 point for your final answer. All right, this next question says find the average number. So we're talking about AVT. Find the average number of fish that leave the lake in the 5-hour period. All right, so they're talking about leaving. So now we're looking at the function L of t. And since they said the average, again, we're using AVT. So that's 1 over b minus a, integral a to b of our function. Literally just setting it up, writing it down, and then integrating that into my calculator. I get 6.059, which tells me that the average number of fish that leave the lake per hour from midnight to 5 a.m. is 6.059 per hour. All right, so again, I'm getting 1 point for that integral setup, literally writing down that integral, and then 1 point for that answer. Part C says, at what time t from 0 to 8 is the greatest number of fish in the lake? So we're trying to figure out when do we have the most amount of fish, the absolute most. That's telling me I have an EVT problem, this extreme value theorem, because we're looking for the absolute greatest. So what I realize is that the rate of the number of fish in the lake at any given time is literally however many are entering minus however many are leaving. So like the rate at which they enter minus the rate at which they leave. And so because we're doing an EBT problem and we want to find the greatest number, we understand that we have to find the values at our endpoints and the values at our critical numbers. So I'm going to start with the critical number. And remember, your critical number is where your derivative equals 0. Since E and L are already derivatives, or already rates, I'm just going to take E minus L and I'm going to set that equal to 0. I'm going to do a quick solve in my calculator and get T equals 6.204. All right, so now I'm going to check that critical number and check my endpoints. The first endpoint I checked was 0. So I did the integral from 0 to 0 of E minus L. Well, that's just 0. All right, which kind of makes sense because at time t equals 0, nothing's actually happening. All right, so then I checked from 0 to the 6.204 of my function E minus L, and I got 135.015. All right. And then lastly, I have to check my last endpoint, so from 0 to 8, and I plugged that in, and I got 80.920. So that tells me the greatest number of fish in the lake is at time t equals 6.204 because that is the highest number of 135.015. So for this one, you're getting 1 point for literally recognizing that you had to subtract E minus L. You had to set that up to get your critical number. You're going to get 1 point for the answer. All right, so for the 135.015, and then or showing that, and then 1 point for justifying why it's the greatest. It's the greatest because it's the highest number from the endpoints to the critical number. All right, part D says, is rate of change in the number of fish in the lake increasing or decreasing? So we're asking about the rate of the rate, right? Is the rate increasing or decreasing? That is your second derivative. And so basically all I need to do is figure out the sign of my second derivative. And I'll be good to go. But again, since E is already, or E and L are already rates, I'm simply taking the derivative of that. That will give me the second derivative. All right, so for this, I'm going to take E prime of 5 minus L prime of 5, and I get a negative number. Of course, that's less than 0. Since that is less than 0, that's telling me that the rate of change in the number of fish is decreasing at time t equals 5. So I'm getting 1 point for even thinking about the derivatives of E and L at 5, and then 1 point for the answer explaining that the derivative of the difference is less than 0. All right, the next question says we have a continuous function f on a closed interval from -6 to 5. The figure below shows just a portion of the graph. Notice that that graph only starts at -2. This graph contains 2 line segments and a quarter of a circle centered at 5, 3. And so then they also told us that the point 3, that we know the point 3, and that's 3, 3, -√5, and that is on the graph. All right, so part A says if the integral from -6 to 5 is 7, find the value of -6 to -2. So basically they're asking for us to find the value of the portion that we can't see in the graph. And so what I recognize is if I'm trying to go from -6 to 5, that is equivalent to going from -6 to -2 plus -2 to 5. So again, if I add -6 to -2 plus -2 to 5, I should get -6 to 5. From here, I'm literally plugging in what I know. So I know that -6 to 5 is 7. They told us that in the question prompt. I'm trying to find -6 to -2, so that's going to stay in my problem. And then I need to figure out what the value is from -2 to 5. So what I notice is that this area in here and this area, those areas are going to cancel. And then this area and this area, those areas are also going to cancel because I have a piece above and a piece below of the same area, and on the other side, a piece above and a piece below of the same area. So what I did was I started calculating everything else, because nothing else is going to cancel. So I knew this box was 1, and then I calculated the area of this triangle as 1/2 base times height. So 1/2, 1 times 1/2, or sorry, 1 times 2. And then I was trying to calculate this lower piece of the curve of the circle. So what I did was I kind of like made a little box, and I recognized that that was a 3 by 3 box. And so the area of that 3 by 3 box is 9. And then what I did was I subtracted off this quarter of a circle. So I did 1/4 pi r squared, and 1/4 because it's only a quarter of the circle. And so the rate or the radius of this circle is 3. So I did 1/4 pi 3 squared, which is 9/4 pi. So you can see that in my equation, I took the area of the whole rectangle and subtracted off the quarter circle to get the remaining piece underneath the circle. All right, so from there, I simplified my calculations. So I have 7 equals the integral, and then I have to add on the 11 minus the 9/4. And then I solve for the integral by moving the 11 and the 9/4 to the other side. And so I get that the area from, or the integral from -6 to -2 is 9 pi over 4 minus 4. So for this one, I'm getting a point for the initial setup. Again, I can't stress enough how important it is to show your work. You get a point just for setting up the problem. And then I got a point for accurately calculating the integral from -2 to 5. So calculating the area in the picture. And then 1 point for my final answer. So calculating out to where I'm actually solving for the integral, I'll get 1 last point. All right, the next part says to evaluate the integral from 3 to 5 of 2f prime plus 4. So I'm using my properties of integrals to separate this out, pull the 2 out, and then separate the 2 pieces of the integral. Using the fundamental theorem of calculus, I know that the integral of f prime is simply f, and I know the integral of 4 is 4x. So I have 2f of x from 3 to 5, and then I have 4x from 3 to 5. Plugging in my bounds, I get 2f of 5 minus 2f of 3, and then plugging on the other side, I have 4 times 5 minus 4 times 3. Simplifying that out and using my picture, I have 2 times 5 because from the graph, I know f of 5 is 0. So 2 times 0 would give me 2 times f of 5. And then minus 2 f of 3. And they gave us f of 3 in the question prompt, right? From the very beginning, they told us that f of 3 was 3 minus root 5. Simplifying some more, I end up with 8 minus 6 times 2 root 5, or basically 2 plus 2 root 5. All right, so we get 1 point for the fundamental, so 1 point for saying that the integral of f prime is f, and then 1 point for the. All right, part C says the function g is given by this another integral from -2 to x. Again, the second I saw that x on the integral, I automatically felt that this was about to be another fundamental situation. So this one wants us to find the absolute maximum. And so again, the second I hear that word absolute, I know that this is an extreme value theorem problem, so an EVT problem. All right, so the first thing I know that I have to find for EVT is my critical values. So I have to find the derivative of g. Using the fundamental theorem, I know that g prime is the same thing as f of x. And I need to set that equal to 0 to get my critical numbers. And so looking at my graph, I know that f equals 0 at -1, 1/2, and at 5. And so that means g prime equals 0 at -1, 1/2, and 5. Now, I don't have to test all of those critical numbers because I'm looking for a maximum. And so at -1, we're going from like a positive or a piece that's above the axis to a piece that's below the axis. So a plus to a minus, that would give me a maximum. But at 1/2, I'm going from minus or below to above the axis. So that's going to actually give me a minimum. And so I don't need to test 1/2 at all. I will test 5 because 5 is also my endpoint. So remember, for EBT, you're testing your criticals and your endpoints. And in this case, I'm going to start with -2. So that is my first endpoint. So I have the integral from -2 to -2. Again, that's no change. So that integral is 0. And then I'm going to test -1 because I know that could have been a maximum. So I have the integral from -2 to -1, literally just calculating that area using 1/2 base times height. So that is 1/2. And then I'm calculating g of 5, so the integral from -2 to 5, which we calculated earlier in the previous part of this question, and we get 11 minus 9 pi over 4. Well, to figure out which one's a max, I just look to see which number is bigger. You do have to kind of be a little bit savvy to know that 9 pi over 4 is approximately, I would say, like, I don't know, 27-ish over 4. And so subtracting that out, I mean, you're going to get a number definitely greater than 1/2. And so because of that, I know that 11 minus 9 pi over 4 is going to be my absolute maximum value. Again, remember the absolute maximum is a y value. It happened at x equals 5, but the actual maximum is the y value of 11 minus 9 pi over 4. So again, I'm getting 1 point for that fundamental theorem saying that g prime equals f. I'm getting another point for making sure that I checked -1. Again, if you had checked 1/2, you wouldn't be wrong. You wouldn't lose any points for that. It just wasn't necessary. And then you get 1 point for the justification, which is your work showing your endpoints and your critical numbers, and then answering the final question. All right, part D asks us to find the limit, and we all know that the first rule of a limit is simply to plug it in. So that's what I started with. I literally just plugged in 1 everywhere I saw x. So I have 10 to the 1 minus 3 f prime of 1 over f of 1 arctan of 1. Simplifying that out, I get 10 minus 3 f prime of 1 is 2 because the slope at 1 is 2. Over f of 1 is 1 per the graph, and then we know arctan of 1 from pre-calc is pi fourths. So simplifying that out, I get 10 minus 6, which is 4, over 1 minus pi over 4. And to make my answer look a little bit prettier, I multiply the numerator and the denominator by 4 to get rid of that double fraction. So I get 16 over 4 minus pi. And this one was pretty straightforward. We didn't have to do L'Hopital's or anything like that. So they only give you 1 point for your answer. The next question says, consider the family of functions. We have f of x equals 1 over x squared minus 2x plus k, and k is a constant. Part A says, find k such that the slope of the line tangent to the graph at x equals 0 equals 6. So again, let me say it again. The slope of the line tangent, so the slope or the derivative at x equals 0, we need that to equal 6. So I'm going to start by taking the derivative of this function. Again, I'm just literally using either quotient rule, or you can use chain rule, or even quick derivatives to figure out that slope. And I know that we're looking at that slope at 0, so I went ahead and plugged in 0 and simplified. So I know that slope at 0 has to equal 6, so I set that slope equal to 6, and then I began to solve for k. So I multiplied k squared on both sides, then I divided by 6 to get k squared equals 1/3, or k equals technically plus or minus 1 over root 3, but they told us that k was greater than 0, so I didn't need the minus part. And so that was pretty straightforward, but I got 1 point for my derivative. I get 1 point for the denominator of my derivative. I guess doing the whole low or the bottom squared, and then 1 point for the answer. All right, so for the next one, they said let k equal -8. So I'm literally taking that function, I'm plugging in -8, and then they want us to integrate from 0 to 1. So I literally plugged in that -8. I noticed it was factorable, so I factored it. And the second that I was able to factor it, I knew that I was going to have a partial fraction situation. So I set up my partial fractions, multiplied, to get that common denominator. I set it equal to my numerator, and then I solve for a and b. So I got a is a 6 and b is -1/6. So then I plugged that into my function and integrated to get 1/6 ln x minus 4 minus 1/6 ln x plus 2. You can go ahead and stack this back up using log rules. I left it as is because it really didn't affect my life either way, but you could have stacked it. We would get the same answer. All right, so then plugging in my bounds, I get 1/6 ln 3 minus 1/6 ln 3. We know that's going to cancel out. And then plugging in 0, I get negative or minus 1/6 ln 4 plus 1/6 ln 2. And so cleaning that up, I pulled out the 1/6, I restacked it, and then I simplified. Again, any of what you had in, or any of what I had in that last line, whether it's the first piece, the second piece, or the third piece, any way that you wrote it is fine. You don't have to simplify it any more or any less than what I did. I was just trying to make it a little pretty. Again, on the AP exam, do what you're comfortable with, understanding that you don't have to simplify that all the way out. So you're going to get 1 point for your partial fraction. You're going to get 1 point for taking the integral or finding the antiderivative, and then 1 point for your final answer. All right, part C, same type of question. They said let k equals 1 and integrate again from 0 to 2. This one's a little bit different because when I factored my denominator, I got x minus 1 squared, and I recognized that I had a vertical asymptote at x equals 1. And I know that's problematic because my bounds on my integral go from 0 to 2, and 1 is in the bounds, which means I have to do improper integrals. So I'm setting up my format for improper integrals. Remember, you can't have the 1 on the bound of your integral because we know that that's our asymptote. So I set up the limit from 1 on the left and then the limit from 1 on the right of my function. And from there, I integrated and then plugged in my bounds. All right, the second I plugged in my bounds, integrated, plugged in those bounds, I noticed that I still had this b minus 1 in my denominator, which means at 1, I still have an asymptote, right? The asymptote didn't go away. And so because I still have an asymptote, I know when I plug in the 1 from the left or 1 from the right, I'm still going to get infinity or negative infinity, depending on which side I'm on. And so I really didn't have to solve out the whole problem. I just noticed that it's going to be like one of my infinities, and I know the second I get infinity, I can simply say that the integral diverges. All right, so I get 1 point for the improper integral setup, 1 point for the antiderivative, so actually integrating it properly, and then 1 point for my reasoning, which my reasoning is that it went to infinity, therefore it diverged. All right, so again, when it says reasoning, a lot of times that is just your math. You don't have to be super wordy.